As one last example, let's consider show depth. So show depth is going to take a GUI like this one that has hello, okay, and cancel. And perhaps for debugging purposes, it's going to adjust the label of everything to show how deeply it's nested inside of horizontal and vertical panels. So hello turns into one hello because hello is just inside this vertical panel. But OK turns into two OK because it's inside the vertical panel and also inside the horizontal panel. Cancel button is at the same level of nesting as the OK button there. So again, the data analysis is that we're working on a GUI. We know how that goes. So we've already got a representation of GUIs. We even have a template and so on, and we've got a bunch of useful test cases maybe. So let's just grab all of this and change it from enable to show depth. So show depth of labels, buttons. We don't need the different OK versus not. Also, we don't have the second argument here. So I'm just getting myself set up with some parts to examples. Okay, I don't have the right answers in there yet. Okay, and the vertical case, show depth. All right, what should the right answers be now? So how deeply nested is this label hello world? It is not nested at all, so that should be label 0 hello world at the end. How about this OK button that's currently enabled? Again, it's not nested, so it should be 0 OK. The choice is not nested, so we want to put zeros on the front of all the items. This horizontal panel, though, it's nesting the OK and cancels button. So in this case, the button should stay disabled, but it should get ones in front of it. And this last one, again, we have nested at depth 1 inside the vertical panel. Okay, so this is what show depth is supposed to do. It's really just counting the nesting for each of them. And we might add one more test case just to show how the number can go up to 2 if we put a horizontal panel around this and add a button, let's cancel at the end. Then we still have a horizontal panel with that same vertical. We've got a button cancel that's nested by 1, but I need to fix these because these are nested by 2 instead of 1. So this is a set of examples for show depth. Let's see what happens when we try to implement this function. We know how the template goes. It's the same template because it's the same kind of GUI. So it's going to be show depth here. We don't have the name string this time after all. So the recursive calls are to show depth with no extra arguments. All right, that should be our template, following the recipe at least. And we're ready to implement this considering the cases. All right, so when we look at the label case here, we're supposed to get something that's like the input except there's a 0 on the front. So we could write that here. We could make label 0 added onto the front of whatever the other label was, like that. But this feels a little suspicious, right? Are we always going to get a 0 at the end? The same thing's going to happen with buttons. But when it recurs down here, we're going to make 0 pick. How does that end up being 2 pick? And when you look at this and try to make the examples match up the code in our last step, it's going to turn out not to work right. So the problem is that this is an example of a function that needs more information in each of these calls. When we're making a label, we need to know something about how we got to this label, for example, to use the number 2 instead of 0. So this is a case where we need a different function than the one we had. The way that makes it work is that we need to accumulate information from the outside. So I'm going to call this show depth at and take a number n as input. And that n is going to tell us how far down we are. So if we start at the beginning, we might start with 0. But if we're at depth 4, say, then the answer we're going to get is 4 out. So this is a case where I followed the recipe and hit a kind of dead end that told me I need an accumulator, and so I have to update all of my examples. So these are all corresponding to show depth at with 0, or I could pick other numbers, but I'm just going to update them to use 0 mostly. And we can try this again now. So this is show depth at. Our template stays the same, except we have this extra number that maybe is along for the ride. But it's not quite that, because we were motivated to put this number in as an accumulator, right? Accumulators are not just along for the ride. Something is going to happen more interesting at these recursive calls that we will consider. So let's fill in the accumulator. Adapting everything to show depth at. All right, and try again. So now the reason our example hello world gets a 0 at the front is because we were at depth 0. So now we're going to have the number and then the empty string and then text. This plus ampersand operator is just a coerce to a string and then concatenate kind of formatting operator. Right? So this will do the right thing now. G matches label T, so the T corresponds to hello world. The 0 comes from N. We put it together with a space in between. The same sort of thing is going to happen with buttons. So I'll have a button with N and a space and the old label, and the enabled state doesn't change. What about for choices? We've been having a helper function that it turns out we didn't need, but it seems like now we do need to add. So we want to show depth on a list, and in fact a thing that often happens is you need to pass your accumulator on to the helper function. So if we have a helper function that changes all the names in the list of choices for us, then we can use that and put them back together in a choice. So here is one of those cases where you discover that you do need a helper function that doesn't already exist. And so you do a nested process here to make that function. So I want a show depth list. What do I want it to do? I write some examples. I want show depth list of the empty list. That means I had no choices, so I should get the empty list back, no matter what number I pass in there. But if I pass in a list that is non-empty, right? So we got the empty case, and this is the cons case, disguised as using square bracket notation. Then I want for apple back and for banana. Okay, what does my template look like? My template is I'm matching on that list of strings with either an empty case or a cons case where I have a string and the rest of those lists. Okay. In that case, I've got the string to work with. I have the rest of the string to work with. And okay, this list of strings is a list of strings. I probably want to use the self-helper function here on that rest of the list. Oh, sorry, I forgot the n for the depth that we're at because I need to pass that along. Now I can go case by case. In the empty lists, I just return empty. In this case, apple corresponds to the string, so I'm going to take that number, append it onto the string, and that gives me the for apple part. I have a recursive call where I work on the list banana, and that will give me back the for banana, so then I can just cons those back together. Okay. So if I use enough dots, then I should be able to run my tests already to make sure that the show depth list works. So let's do that. Okay, so we got various tests failing, but the first test that fails is at show depth at, right? They're all after that. So that means I've done my nested process here for show depth list. And finishing up here is straightforward. I just want to horizontally compose there and vertically compose here. This is where I have those recursive calls though. And so maybe that I needed to think about it more, but let's just try this. I have to spell things right. Try again. Oh, I still have failing tests. Let's look at the first failing test here. I got 0 OK, 0 cancel, and I wanted 1 OK, 1 cancel. Why did that happen? It's because I have this recursive call here at the same depth n, right? So my examples, when I go back and think about them more, either upfront or after I discover with test cases, help me realize that I need to increase the depth for these recursive calls. And when I do that, now all of my tests will pass again. Okay, so we have quite suddenly reached the end of show depth at. If I really wanted a show depth function, if people wanted show depth, not show depth at, then I can, this often happens with an accumulator function, that you write the accumulator version, and then you write another function that just starts it off with a suitable initial value. So I could take my show depth examples that I had before and use them as tests for this completed show depth function. So what show depth illustrates is how the design recipe adapts when you need information in recursive calls from the context of the call. That is, when you need to use an accumulator like this. It's a pattern that will show up a few times in the kinds of programs that we write.